This is chapter 7, which is part of organic chemistry, and the topic that we will study today from this chapter is the phenols. Talking about the phenols, so if the benzene ring has one hydroxyl group attached to it, that is called as the phenol. Phenol are also referred as the carbolic acid, benzenol, or monohydroxybenzene. You can simply say that the parent compound of phenol is the monohydroxybenzene. Mono means one, hydroxy is the hydroxyl group, which means that one hydroxyl group is attached to the benzene aromatic ring. In this picture, you can see that you have a benzene ring to which the hydroxyl group is attached. If I do the numbering that on which carbon the hydroxyl group is attached, then by default it is carbon number 1. The point to keep in mind here is that the hydroxyl group in the phenol is always by default attached to the carbon number 1. Phenol is also called as the carbolic acid, benzenol, or monohydroxybenzene. Classification of the phenols. Depending on the number of the hydroxyl groups that are attached to the benzene aromatic ring, we have the classification of the phenols. It can be classified as monohydric, dihydric, or trihydric phenols. If one hydroxyl group is attached, that is called as the monohydric phenols. If we have attachment of two hydroxyl groups, that is the dihydric phenols. And if three hydroxyl groups are attached, then it lies in the classification bracket of trihydric phenols. This is the example. Here you can see that phenol itself is a monohydroxybenzene, so it lies in the monohydric phenols. For dihydric phenols, we have two hydroxyl group attached to the benzene ring. Keep in mind that the position of the hydroxyl groups might vary. The third is the trihydroxybenzene. Here we have three hydroxyl group attached to the benzene ring. This is an image that I have added from the curriculum. Here you can see that the first structure, that is phenol, which is monohydroxybenzene, is also referred as the benzenol. A phenol to which on second position you have hydroxyl group attached is called as the catechol. If the hydroxyl group on phenol is attached to the third carbon, it is called as the resorcinol. And if we have second and third carbon occupied with the hydroxyl group on phenol, it is called as the pyrogalloy. For hydroquinone, we have the attachment of the hydroxyl group on the fourth carbon of the phenol ring. You get this in your structures. The easiest way to memorize it is that in class you have your CRs. So C is for catechol, R is for resorcinol. Catechol you have second carbon hydroxyl, and in resorcinol you have hydroxyl on the third carbon. Hydroquinone is for the fourth and pyrogalol is for the first, second and third hydroxyl. What is the keyword? In class you have CRs. So C means first and second, R means first and third. C comes first, R comes afterward. So C has first and second, R is first and third. Hydroquinone is first and fourth. Pyrogalol is first, second and third. This is the easiest way to memorize these structures. Benzenol is the monohydric, catechol, resorcinol and hydroquinone. These three are the dihydric phenols. The attachment of the second hydroxyl group is on different carbons, but the phenol, that is the first hydroxyl, is by default at the first carbon of the benzene ring. And for pyrogalol, it is a trihydric phenol, so it has three hydroxyl groups attached to the benzene ring or two hydroxyl groups attached to the phenol ring. Talking about the structure of phenol, here you can see that in phenol we have a benzene ring, and to that benzene ring the hydroxyl is attached. In benzene ring we have alternate double bonds between the carbon-carbon atom, which means that it is alkene. A double bond is present, and we know that for double bond the hybridization is sp2, which means in phenol the hybridization of carbon is sp2, whereas for oxygen it is single bond, so it is sp3. The bond angle here will be 109 degree. How you can report it? That in phenol the aromatic ring is attached to an hydroxyl group. The oxygen atom is sp3 hybridized, whereas the aromatic ring is sp2 hybridized. So we have sp3, sp2 sigma bonds. Keep in mind that oxygen has two lone pairs of electrons, and because of the lone pairs that oxygen have, the geometry is the band shape. What are the key points to remember here? That for the aromatic ring, the benzene ring, the carbon atom is sp3 hybridized. The oxygen atom is sp2 hybridized. Between carbon and oxygen we have single bond, so it is sp3 sp2 hybridized. Since oxygen has two lone pairs of electrons, so its geometry is distorted and the shape is bent. Because of the lone pair of electron, the bond angle also changes to 109 degree. You can simply report all these key concepts, draw the diagram, and you get full marks for the structure. Keep in mind that the aromatic ring, that is the carbon, is sp2 hybridized and the carbon oxygen is sp3. So you have sp3 sp2 sigma bond for the phenol. In this video, we have studied the detailed analysis of the phenols, introduction about the phenols, classification of the phenols with the board related questions that I have discussed in the initial of this video, starting of this video, and now the structure of phenol. Keep in mind that oxygen has two non-bonded electron pairs. When you get this question in your board examination, make sure that you attempt such questions because these questions give you full marks. Make sure that you watch the videos completely. Thank you so much.